Hi everybody, in this video we're going to be walking through your MATHia workspace called Developing Definitions of Rigid Motions. On the left side we have our content where we're going to read through, and then my right side we're going to have some questions to answer. So translations. Recall that in geometry one type of rigid motion is a translation or a slide. Also recall that a function is a rule that assigns exactly one output to each input. The input to a function can be a point. A translation is a function t, which takes as its input a set of pre-image points and outputs a set of image points. The pre-image points are translated a distance AB in the direction AB. When a figure is translated, the resulting figure is congruent to the original figure. Consider the line segment PQ, as I can find right here, perpendicular to CB, because it has a little square there. Translate PQ using the translation function TTR PQ. To translate PQ, first determine the direction and distance that PQ will be translated. The function tells you that PQ will be translated in the direction TR, and the distance measure of TR. Draw lines parallel to the translation line, TR, so that's right here. That's where they're getting the TR, and the distance TR in between the two is the distance that we're translating PQ. Draw the point P prime so that P prime, here to here, has the same direction as the translation line TR, the same length as the measure of TR. Draw point Q prime so that we have Q prime has the same direction as the translation line TR and the same length as TR. So now we've got the translation direction with TR and length TR, PQ, becomes P prime Q prime. The line segment P prime Q prime is a translation of line segment PQ. It is the output of the input PQ in the translation function. Line segment PQ was translated the measure of TR in the direction of TR, the ray. So here we have some true-false questions here. Decide whether each statement about the example is true or false. Is P prime Q prime congruent to PQ? Since it was a rigid motion, all we did was translate. They should be congruent. Is P prime Q prime perpendicular to BC? Since P prime and Q prime is parallel and the same as PQ, it should, if we were to extend, be perpendicular to BC. So we're going to go with true. Is the measure of QQ prime not the same as the measure of TR? Now, due to the way that we translated, we made sure that the distance between Q and Q prime is the same as TR, so that is not true. And then it asks pretty much the same thing, P to P prime, is that not the same as TR? That would also be false. Now we've got, is TR parallel to QQ prime? And since we made sure that we drew parallel lines here, that would be true. Complete the statement about the example. Line PQ was rotated, dilated, translated, or reflected, was translated in the direction of TR, that's the one that we used this whole time, in the distance of TR. As long as we were reading, we made sure that we had all of that information. Now we have the diagram below shows the function tgk, which means that we're going to be looking at measure for gk and direction gk, sv. So here's my sv. Line GW, right here, is parallel to the line segment SV. Use a diagram to answer the remaining questions. So this is similar, but a new problem from our example. The input of function is the figure SV. So that's where we're starting, right? That's our input, SV. The output of the function is the figure. So when we finish our translation, we are going to again end up with S prime, V prime. Line segment SV is translated in the direction of, remember we are using GK, so GK. The measures of S, S prime, and V, V prime are equal to the measure of the line segment. Remember it is GK, and in this case we have to type it, GK, and don't forget to press your enter button. Line segment S prime V prime is, or is not, congruent to the line segment SV. Since it's a translation and a rigid motion, we keep same shape and size, so it is congruent. And is or is not parallel to GW. Remember we talked about GW being parallel to SV, and if S prime V prime is pretty much the same thing, but translated, it should also be parallel to GW. So that is your first problem here, dealing with translations. As you continue through this workspace, you'll also encounter reflections, rotations, and dilations. So make sure that you're reading carefully on your left side here, and then answering on your right side over here. If you have any other questions, make sure that you use a hint, or if a step-by-step or sample problem is available to you, make sure you use those tools, or you can always contact me if you need any other help.